Today I'll be concerned about chemical oxidation. Now, oxidation state of an element is the combining power of that element. Now, when we say change in oxidation state, then we're talking about change in the combining power of that element or the chemical species in that reaction. Now, I will be demonstrating change of oxidation with potassium permanganate and iron 2 solution. Now, iron 2 will be undergoing oxidation or change in oxidation from iron 2 to iron 3, while potassium permanganate, manganese in 7 plus, will be undergoing change in oxidation state down to manganese 2 plus. Now, the pink or the purple color is due to Mn7 plus, which is manganese 7 plus. When it is reduced to 2 plus, Mn2 plus, it will now be colorless solution. Now, this is ordinary water, distilled water. Now, watch. Now, there is nothing in this water to oxidize, or so to say, to reduce potassium permanganate. Immediately you turn it to the water, now the pink color is sustained. But now, this is iron 2 solution. Now, when you turn potassium permanganate into iron 2 solution, now manganese 7 plus is reduced to manganese 2 plus, which is colorless solution. Watch. Now, nothing. Fe2 plus is oxidized to Fe3 plus. Now it undergoes oxidation, while Mn7 plus is reduced to Mn2 plus, which is colorless. So that has led us to arrive at this colorless, relatively colorless solution. But for a solution, for a water that contains no chemical species to reduce or oxidize anything, immediately the potassium permanganate is turned, you see the pink color is sustained, while in this it was reduced to colorless. Thank you very much. The first video. Now, back again to this channel, chemistry demonstration. I call it chemostration. Now, in this chemostration, we are going to demonstrate change in oxidation states, change in the combining power of a chemical species. Now, when potassium permanganate with Mn7 plus is dissolved in water, it appears pink in solution. Now, that pink color is imparted by Mn7 plus. But when it is reduced to Mn2 plus, it turns to colorless solution, which is demonstrated in the previous video. Now, this time around, we're going to demonstrate how Mn7 plus manganese 7 plus is reduced from 7 plus to 6 plus to 5 plus to 4 plus. There it will stop. Now 4 plus happens to be a brownish color, but in a very light concentration or dilute solution, it appears yellowish brown. Now let's demonstrate. Now this is the potassium permanganate solution. Now here I have sucrose solution. Now again sodium hydroxide solution. Now I will mix the sucrose solution and potassium permanganate, sucrose solution and the sodium hydroxide solutions together. Now, I'll turn it to the potassium permanganate solution. Watch. Now, it's undergoing the reduction process from Mn7 plus to Mn6 plus. Okay, you can observe the change in color. It's now Mn6 plus. That is manganese 6 plus. That is going to the next oxidation state, the reduction process, manganese 5 plus. It has turned from purple or pink to blue first, now is green. Now this process will be faster if some level of stirring is applied. Now the green color is getting lighter to turn to yellowish brown because manganese 4 plus in dilute solution appear yellowish brown, but its actual color is brown. Now you can see the yellowish color coming up very clear. Now, this is what we call chemical chameleon. A color change occurs from pink to blue to green to yellowish brown. Chemical chameleon. Please don't forget to like, subscribe, and click the notification button. And not only that, please do well to share to promote this video. You are up with Danpere, empowered by Danpere Chemtech. Thank you very much. Bye-bye.